Click the bell icon to get latest videos from Ekeeda.
Hello friends, you have learned how to form a differential equation by eliminating the arbitrary constant. In this chapter, we will see how to form a partial differential equation by eliminating an arbitrary constant as well as eliminating arbitrary functions when you have three or more independent variables on which your function is based. Let us take an example to understand it better. We have 2z is equal to x square by a square plus y square by b square. Let us form a partial differential equation using the given expression. Let us first differentiate z partially with respect to x as well as partially with respect to y. Thus, differentiating z partially with respect to x, we got 2x upon a square, and differentiating z partially with respect to y, we got 2y by b square. Now, rearranging the terms, we can get the value of 1 upon a square and 1 upon b square as follows. 1 upon a square will be equal to 1 upon 2x del z by del x, and 1 upon b square will be equal to 1 upon 2y del z by del y. Now, going ahead, we can substitute these values in the given equation. Thus, Thus, by substituting the values of 1 upon a square as 1 upon 2x del z by del x and 1 upon b square as 1 upon 2y del z by del y in this equation, and further simplifying this equation, we have got 2z is equal to x del z by del x plus y del z by del y. This is our final partial differential equation of order 1. Why this is partial differential equation of order 1? Because we have first order partial derivative of z with respect to x and first order partial derivative of z with respect to y. Thus, we have formed first order partial differential equation by eliminating the arbitrary constants a and b here. Let us move to the next question. The next question is z is equal to x plus y into phi of x square minus y square. Here, phi is a function of x square minus y square. Now, to find a partial differential equation from this expression, we have to differentiate z partially with respect to x and differentiate z partially with respect to y. So, let us start the solution. So let us differentiate z partially with respect to x and y. Here we have differentiated z partially with respect to x. If you see, we have used the u into v formula of derivatives. So u derivative of v into derivative of x square minus y square plus v derivative of x plus y partially with respect to x will be 1. So only 5 into x square minus y square. Transferring 5x square minus y square on the left hand side, we will get also from the question we can say that phi x square minus y square is equal to z upon x plus y. So I will write let us consider this as equation 1. Now let us differentiate z partially with respect to y. Here we have differentiated z partially with respect to y, again using the u into v rule. So we have u derivative of v plus v derivative of x plus y partial with respect to y will be equal to 1. Again, transferring phi x square minus y square on the left hand side, we get now we know that phi of x square minus y square from the question gives us z upon x plus y. So we have got our two equations. Now, when we divide the first equation by the second equation, we get the following step. This is what we get when we divided equation 1 by equation 2. Now you can see that on the right hand side, x plus y and phi dash x square minus y square will get cancelled. Also, 2 will get cancelled. What remains is minus x upon y. On the left hand side, when we take LCM and multiply x plus y, then x plus y as the common denominator will get cancelled. What remains will be like this. Let us cross multiply and simplify this further. Open the bracket, multiply y to the bracket, multiply minus x to the bracket. Let us see what do we get in the next step. Let us take the terms with partial derivatives, that is del z by del x and del z by del y on one side, and let us take the remaining terms on the right hand side. Taking common from left hand side and right hand side, we get the following step. In this step, if we assume del z by del x to be p and del z by del y to be q, we can write this in short as follows. So here we have assumed del z by del x as p and del z by del y as q. Taking the right hand side to the left hand side and taking x plus y common, we are left with the following answer. This is our required first order partial differential equation derived from the given expression. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.